per unit. So if per unit influence is this, then the change now in Q1 is 5. Then I just got 5 times of the influence, right? The whole influence or the total influence is actually 5 times of per unit influence. Is that clear? All right. So not only Q1 may change, but also Q2 may change. So we have another term, partial U, partial Q2, dQ2, the same logic. And this is the marginal influence, or we call it per unit influence, per unit change of Q2 on the change of U1, of U. And this is the differential of Q2, which means the change in Q2. So if this is like 3, the change is 3 units in Q2, and this is the influence per unit. Then we got the total influence from Q2 would be 3 times of this per unit influence, right? The total influence would be 3 times of the per unit influence. Is that clear? So this term and this term, the partial differentiation term, which means without the change of another variable, so only Q1 changes, and Q2 remains constant here. So per unit change of Q1, we want to know the effect of per unit change in Q1 on the change in U. And this is per unit change of Q2 on the change of U. So when Q2 changes, Q1 is assumed to be constant, okay? Unchanged for Q1 here. And this is the change, the size of the change in Q1, the size of the change in Q2. So just multiply. And this is the total effect of the change. All right? And this is actually the total differentiation of the right-hand side. This is the result, the total differentiation result of the right-hand side. And this is the total differentiation result of the left-hand side. And they must be equal, right? Because this is an equation. So we just take total differentiation of both sides and we make them equal. Okay? And the idea here is very important, okay? Let me show you. What would be dQ2 over dQ1? We just do some manipulation. We have dQ2 here, we have dQ1 here, and we may we may move this term to the left-hand side, right? Because the left-hand side is 0 now. We move this to the left-hand side and move dQ1 to the denominator. So we may have a negative sign and partial U, partial Q1, partial U, partial Q2. Is that right? We may restore the equation back to here quite simply, right? Because now Q1 is on the horizontal, Q2 is on the vertical, so this would be the slope of the indifference curve, right? The slope of the indifference curve, right? The slope, slope. this is an indifference curve, right? Indifference curve. And this captures the slope. For example, here, the slope of the indifference curve, is that right? So the slope of the indifference curve is a negative one, We have a minus sign here. If we have a positive term on the numerator and denominator, then it must be negatively sloping one. A negative slope. Okay, so next, what is this? What does it mean? Think. This is an utility function, and we may have this term. What does it mean? I just told you that this is the per unit influence of Q1, right? Per unit change in Q1 on the influence of per unit change in Q1 on the change of U. So it's actually, we call it marginal utility. This is marginal utility of good one. Marginal utility of good one. And this, of course, marginal utility of good two. So the marginal utility, either good one, of good two, or good two, is something that marginal utility of good one, we call it MU1. MU1 is the single effect coming from Q1, the change in Q1 per unit, only one unit, with Q2 remain constant. Okay? And MU2 is the marginal effect, marginal influence of Q2, of good 2. It's a 1 unit change in Q2 and the influence on Q1, on utility. So we call it marginal utility of good 2, marginal utility of good 1. Or, if you are lazier, you just U1 subscript U subscript 1, U subscript 2. Subscript means 下标, okay? Subscript. So we just use this to represent marginal utility. Same thing. So you may use this notation or this. Alright. Now think about this. What does it mean by marginal utility, the ratio of marginal utilities? Pizza, burritos. So I have a consumption bundle here. So the specific level of pizza, specific level of burritos. I want to ask, what if I just eat one more slice of pizza? What about one more slice of pizza? So say 4 to 5. I want one more slice of pizza. And how many burritos I have to cut to eat so that my utility will remain on the same level? Okay, now I just propose a question here. If I want, all of you may know, for this point, this specific level of pizza and burrito. For this point, I have a level of satisfaction, or I have a utility value. I have a utility value, right? And now I want to ask, what about if I want to have one more slice of pizza? And I want to remain on the same utility level, which means on the same indifference curve. I don't want to change my utility level. And so I want to know how many burritos I have to cut. If I remain the quantity of burrito, and I just have one more slice of pizza, I eat one more slice of pizza, my utility must be raised, right? Must be raised. My utility must go up. Why? More is better, right? The same level of burrito, but one more slice of pizza. So I would be happier. Is that clear? But now, I don't want to be happier. I just want to be the same utility. So I know I have to cut something I like, burrito. If I have something I like, pizza, one slice more, I want to cut. And I just want to know how many burritos I have to cut so that I may remain on the same utility level. Okay, this is the question. So we define this idea as marginal rate of substitution, MR as marginal rate of substitution, which means the maximum amount of one good that a consumer will sacrifice to obtain one more unit of another good. So if I want one more unit of pizza, so the maximum amount of burrito I would like to sacrifice. If I don't have to sacrifice, it's good because I can be happier. But if you ask me, so what is the maximum amount of burrito if you want to have another slice of pizza? So the maximum would be this. And why it is maximum? Because it makes me the same. It makes me the same, not worse. Okay? So if I may cut less than this maximum amount, if I may cut less, I would be on another indifference curve which is farther from the origin, and more is better. So this indifference curve must bring us what? A higher utility level, right? It must be a better one. So the maximum amount we are willing to sacrifice would be this, and making us on the same indifference curve or on the same utility level, so that we may not feel worse. If I ask you to cut more than this maximum amount, and I give you one unit more, one more slice of pizza, you will locate at this point, right? And this point will be on another indifference curve which brings us, or which gives us, a lower utility level. Is that clear? So this would be the maximum amount, and we like to know how much is it. So this is the way we try to calculate the MR as marginal rate of substitution. It's a slope. And remember, because this is actually a very, very tiny thing, so the slope is something like this. Okay, let me give you a real example. Like if I have my consumption of pizza, one more slice, one more unit, I may have 100 points more of happiness. I may have another 100 points. And for each burrito, if the burrito may give us, say, 20, 50. If it is 50, which means one more burrito, you may be happier by 50 points of happiness. Okay? Now, if I have one more burrito, I will be better by 50. I have two, I will be better by 100. But if I cut the consumption of burrito, I'll be 50 points less, 100 points less. Okay? So if I have one more slice of pizza, I got an extra 100 points of happiness. And I have to cut by 1, 2 burritos. So that's plus 100 and minus 100. My level of happiness remains the same level, right? Is that clear? So if this is 100, this is 50, so the ratio will be 2. One more slice of pizza, I am willing to cut 2 burritos. I would like to sacrifice 2 burritos at most. Because when I have one more slice of pizza and cutting 2 unit of burrito, then I would remain on the same indifference curve. Nothing better, nothing worse. Okay? So we call this marginal rate of substitution. It is a slope of a particular point on the indifference curve. So the slope may change. The slope here, point F, the MRS, the MRS, the MRS. So the MRS the absolute value of the MRS may decrease. And there is a reason for this. Think about this. On point F, I have only not too many pizzas, but I got a lot of burritos, right? So at this point, I would say I would regard pizza as a good thing. I like to have something more, right? So here, the marginal rate of substitution, the absolute value of the marginal rate of substitution is quite high, which means I'm willing to sacrifice a lot burritos to have an extra slice of pizza. Because so far pizza, my consumption of pizza is few. Okay? And here in the middle, my willingness, the marginal rate of substitution is right in the middle. So far I have already increased my consumption of pizza here. So the extent I would like to sacrifice would be less than the extent I would like to sacrifice here, right? If I got a lot of burritos and let just only a few pieces, I would sacrifice a lot of burritos. But as the points move along the curve to the right, to the lower right, then my willingness to sacrifice would decrease. And here I already have a lot of pieces, but not too many burritos. And if you ask me how many burritos I would like to sacrifice in change of another slice of pizza, I would say not too many, because I have pizzas as many as enough, right? And now I have only a small amount of burritos. So, well, I will not sacrifice that much as we were at point F. Got the point? So, along the indifference curve, your willingness to sacrifice will decrease. Because when the points move along the curve from the upper left to the lower right, we got more and more pizza and less burritos. Got the point? Okay, let's take a break. It's 10:51, so 11:05. No, because it's on the